recording. We are taking the second half of test 6. It starts on page 445. We're doing it in the intervals. We're going to take the half an hour and then we will go over explanations and questions. It's entirely possible you won't get done with this half, but do the best you can. We are getting to the end of the first 10 minutes. Hopefully you are approaching question 40 or somewhere around there, and we will give you another 10. I will try and announce the 5-minute mark as well, but just to keep you on track. Should be about 5 minutes way through. Hopefully around question 45. All right. We'll take 10 more minutes. Again, do the best you can. See what you know and what you don't know. If you're truly stumped on something, move on and spend the time somewhere else. If you have not yet reached the end of the test, the 5 minutes left are the time that you should be skipping forward to the end and looking to see if there's something easy to answer. And even if you don't get to every problem, make sure that you have a guess for every problem. And pencils down. All right. So, flipping back to 30, go ahead. I'll read off the answers so it's easy to check. Don't worry about writing in the correct answers. You've always got them at the end of the test. So that's not particularly important. It's just helping you check right now. So 30 is J, 31 is E, 32 is G, 33 is D, 34 is G, 35 is B, 36 H, 37 B, 38 J, 39 C, 40 J, 41 D, 42 F, 43 B, 44 K, 45 B, 46 H, 47 E, 48 K, 49 B, 50 G, 51 C, 52 G, 53 A, 54 K, 55 D, 56 F, 57 E, 58 F, 59 C, and 60 J. So I think we're just going to take these the 5 at a time. So first of all, it should actually be 30 through 35. 30 should have been on the last test, but I started us wrong. So on those first 5, are there any that you got wrong but you felt like you should have been right but you're not sure what went wrong? That's the first instinct. I make mistakes too. It happens. Is there any problem that you're like, oh no, I thought I had that right. Where did I go wrong and I'm not sure yet? And the follow-up question, are there any that you are feeling like, I just didn't know where to start with this one, I was feeling a little confused? All right, so for 31, I have double percent. You're taking a percentage and then taking a percentage again. For 32, it's that Pythagorean triple, 3, 4, 5, and then finding the tangent is the opposite over adjacent. For 33, the factors cancel, the same the top and the bottom. And 34, you just have to be able to reduce those radicals. And so if you need help with those, we can go over that one. And then 35, I wrote down definitely do a sketch, and then you're writing out their proportion. And so those are the general categories I would count for those. Were there any that you wanted to see in more detail from those first 5? 35? Okay, so we have a triangle. We actually have 2 triangles. I'm going to erase out this stuff so we have more space.
We have a determinant for ours.
Oh, you have a determinant
Yeah.
of a matrix?
Mm-hmm.
Okay, determinant of a matrix, that is a different one. So what numbers are in the matrix? Just read across the top.
4, 8, 2, 5.
4, 8, 2, 5.
Mm-hmm.
Determinants, you're going to be multiplying the diagonals and subtracting the difference. It's one you haven't learned yet, but it's relatively short, so we'll talk about it, and maybe if you see it again, you get those points. So we take our 4 times our 5 is our first diagonal, and then we're subtracting our second diagonal, which is 2 times 8. And so we have 4 times 5 is 20, minus 2 times 8 is 16, 20 minus 16 is 4. And so those are determinants. I'm glad to know that one's different. The answers I read off are right. I got them from him. So I was getting them from the blue book this time, so we didn't have to fight that like last class. So yeah, determinants, they're kind of random. You don't see them a whole lot, but if you do, they're pretty easy if you know what you're doing. Just do the crisscross. The important thing is you're always going to start with that first thing and go down, and then subtract the cross. Good question. All right. Looking at 36 through 40. Again, my first question is, are there any problems that you felt like I should have gotten this? I thought I knew what I was doing, but it didn't turn out the way I wanted it to. And then
39. 39.
39. All right, I've got Maria posted a time of 37 minutes, 29 seconds. Is that one the right question? Good. Just so I don't talk about it too much. So the first thing is, it says about how many miles per hour. I'm going to turn that 37 minutes and 29 seconds into just minutes. Because 29 seconds versus 30 seconds really doesn't make that big a deal. And so I'm just going to say this is 37.5 seconds. And it's possible that the 0.5 doesn't make a difference either, but that's the first thing I'm going to do to make my life easier. So we know that she posted a 37 minutes and 5 seconds in not seconds, minutes. I'm already mixing up the units. Wasn't making sense for a second. And that was for 5 miles. And they want to know how many miles per hour. So I already said minutes and miles, but really we want miles on top. And 37.5 minutes. So this goes into the conversion. So the first thing of conversion is you always want the units to cancel. So how many minutes are in an hour if we want miles per hour?
$3,600.
You meant seconds.
Oh, sorry.
We just want minutes and hours. So how many minutes in an hour?
60.
60. And if we want minutes to cancel, that means we're putting our 60 minutes over 1 hour. And so we would be running 5 times 60 minutes and 37.5 minutes times 1 hour is going to convert into the miles per hour. And so 5 times 60, that's what, 300? This is calculator work. And then 37.5, the minutes have canceled, it's still times 1, so it's still 37.5. And in order to get to 1 hour, and we get miles per hour, all you have to do is take the 300 divided by the 37.5. And so you could possibly do that without the conversion, but for me, it organizes my brain better. And so that's why I set it up like that. All right, on 36 through 40, anything that you're like, I just did not know where to start. I promise not to hold it against you. All right, so with 36, be aware that those sides subdivide into 2x and x. And so the pieces subdivide into 2 inches and 4 inches. And then from there, it's a Pythagorean theorem of 2 squared plus 4 squared. And you actually get to stop right there because you're looking for that area. And so you don't have to do the square root and find the hypotenuse. You can just stop and say, I found my area. For 37, how familiar are you guys with the circle arc stuff? I don't think I've taught you, but if it's a diameter in a circle, anywhere along this circle will subdivide to a right angle. This diameter is 180 degrees, and this is half that at 90. And that's always true no matter where you draw to on the circle. And so that is the setup for that one. All right. For 38, midpoint should have been like, oh yeah, breather. I remember how to do this problem. Just find the average of the coordinates. And 39, we talked about 39. And then 40, do you understand how to go through a function? You find f of -1, and then you take that answer and plug it into the g function. All right. For 41, now actually I'll pause and ask for questions again. So 41 through 45, questions of, hey, I didn't understand what I got wrong. And then 41 through 45, things that you want me to go over in more detail. Yes? 41? Okay. So, the key to 41 is that if I have x to a fraction, like 3/2, the denominator of this fraction is the same as a root. And so if I have to the 3/2, this is the same as the square root of x to the 3rd. And so that is the key to that problem. We have x to the 1/2. We have y to the 2/4. And we have, oh no, that's 3/4. Copy error. And we have z to the 5/8. So if you look at the thing below, they're all in the same root. And so since the root is tied to the denominator, we need a common denominator first. And so 1/2, 3/4, 5/8, what's our common denominator going to be? Been a long time since fractions?
8.
8. We want our common denominator to be 8. And so we can turn this half into 4/8. We can turn 3/4 into 6/8. And then we have 4/8, 6/8, 5/8. And so our root is the 8th root. That's our common denominator on all of them. And left behind you have x to the 4th, y to the 6th, and z to the 5th. And that's where that one's coming from. Does that help? Okay, awesome. Any other from this set that you would like to say?
42, please.
42? Okay. So this one is solving for a different variable. It's using all of your algebra solving skills, but you don't get to simplify anything because everything's in variables. And you start with the formula A equals 1/2 and h, and then b1 plus b2. And they ask us to solve for b1. This is our goal. And so it's all about canceling it out until we get to just this thing. So go from the outside to the inside. How do we undo 1/2? What's the opposite of multiplying by 1/2? Multiplying by 2. Dividing by 1/2 was the same as multiplying by 2. So we're going to multiply by 2, and we get 2a equals h b1 plus b2. What do we need to cancel out next?
H.
H. All right, so here's H. H is currently stuck to the rest of this by multiplication. How do we undo multiplication?
Divide.
And so we're going to divide both sides by H. And here they cancel. And so we have 2a over H is equal to B1 plus B2. Again, we wanted B1, so how do we cancel out plus B2?
Subtract it.
We subtract it, and so we have 2a over H minus B2 is equal to the B1 we were looking for. So it's a lot of solving, but you don't have to simplify anything. It's just showing the steps of, I would have to cancel this by multiplying, I would have to cancel this by dividing, I would have to cancel this by subtracting. And so you just keep going until you have the target they asked for. Again, very good questions. Anything else on the through 45 mark?
45.
All right. So I have an absolute value. I suppose I should be checking in. Is that what you've got?
Yes.
Okay. So we have the absolute value of x equals x plus 12. I am okay with this one as a plug-in test the answer type problem. There is a theoretical, but I don't think that it's necessarily faster than just checking it. If I put in negative 12, the absolute value of that would be 12. But negative 12 plus 12 would go to 0, and that doesn't work. If I put in negative 6, the absolute value would go to 6. And negative 6 plus 12 would also be 6. And that one works. And so, again, you could think about that more theoretically, but at that point, it's probably faster to just plug in the options they offer and see if it works. All right. Just in general, 43 is a matter of reading the graph and being able to get the numbers and simplifying. And then 44 is just understanding solutions of a quadratic. If it's crossing the x-axis, those are real solutions, and so there are 2 real solutions. 46 through 50. Yes.
Really quick. So how would it be an imaginary solution just for future reference?
Oh, excellent. So if we have a parabola, the solutions are where it crosses the x-axis. It's where x equals 0. And so if it looked like this, there are no real solutions. It's not crossing the x-axis, and so those are only imaginary. Very good question. All right. So 46 through 50. Clarification questions first, and then just, hey, I really want help with this one. What can I answer for you? "46 is, yes.
49.
49. All right, I have the distance between 2 points. Is that what you have? Okay, what have you got?
A geometric sequence is a sequence of numbers in which...
Oh, okay. Okay. What is the constant in the 4-term geometric sequence? 3, 1.5, 0.75. Okay. So, with geometric sequences, it's about you're multiplying over and over and over. With arithmetic sequences, you're adding or subtracting over and over and over. And so the way to find the common ratio is what it's called, is you're just going to divide by the number that came before it. And so what is 1.5 divided by 3? Calculator's fine. 0.5. And so it's just cutting it in half over and over. Half of 3 is 1.5. Half of 1.5 is 0.75. Half of 0.75 is that 3 point, or 0.3, whatever. So, yeah, geometric series, it's a common ratio. It's being multiplied or divided by the same amount every time. Good question. Any others? All right, so for 46, real quick, if you are comfortable with the fractions, know that halfway between is always the average. And so you can just take the average of 1/3 plus 1/2 and divide it by 2. On a number line for 47, you're looking at, well, if I go 20 in the wrong direction, then I'm actually 40 away from the reality, is that conceptual one. And then 48, permutations, the idea of there are 5 things available for the first slot and then there's 4 things available for the next slot. You're comfortable with those. And then 50 was a lot of calculation. How about 51? We're almost out of time, but how did you guys do on that one? So area is scale factor squared. The little triangle compared to the big triangle is 4 times as big. It's going to be 4 times 4 or 16 times the area. And so that one is the key that you need. And all right, we're just going to open it up till the end and probably do 2 more questions. What do you want to see more than anything else before we run out of time? Yes? 54. I have the solutions of a quadratic equation looking thing with B.
Yeah.
Okay. So we have x squared minus 45 b squared equals 4xb, I think. Yeah. So are you comfortable with quadratics? You just don't like the variable one.
Yeah, I just
Okay.
don't like.
So you understand that we have to subtract it over to get it equal to 0?
Yeah.
Okay, so we have x squared minus 4xb minus 45b squared. And then we are looking, the b's just kind of hang out. They aren't affecting our answer so much right now, but we're looking for factors of negative 45 that add up to negative 4. And so factors of negative 45 that add up to negative 4. This is where those multiple choices come in really handy, because you can look at what they've got down there. Factors of negative 45 that add up to negative 4 are negative 9 and positive 5. And so if they're multiplying to negative 45b squared and they're adding to negative 4b, our factors are negative 9b and positive 5b. And as a factored form, we have x minus 9b and we have x plus 5b. So the real question is, on this one, why is the answer k instead of g?
Because you have to set it equal to 0.
Because you need to set it equal to 0. This factor needs to be equal to 0, and so positive 9b is what solves the equation and makes it equal 0. And the same way here, you need that negative 5b. You need the opposite. That's the solution because that's what makes it 0. And so a lot of times, especially when they throw in the variable, it's really easy to say, oh, I've got the answers. But no, you still have to say, I need those opposite to be the solutions. Factors and solutions will be that mirror image of each other. All right, really, really good questions. One more.
Question 60.
60, all right. Oh, this one's a good one because it's fairly simple. I've just lost the eraser. Oh, there it is. So, logarithms is another thing that you have not really dealt with. But if you happen to get this one, you could still do it. Because we have the log base 5 of 5 to the 17 over 3. Yeah, 3. Logarithm is a way of writing exponents. If this were equal to x, this would go over and be the base of an exponent, and so this would be 5 to the x equals 5 to the 17 over 3. Well, if 5 to the x equals 5 to the 17 over 3, what does x equal? 17 over 3. It's just the same. And then, well, 17 over 3, 17 divided by 3, what numbers does that fall in between? 15 divided by 3 would be 5. 18 divided by 3 would be 6. It's going to fall, J, between 5 and 6. And so logs are ones that you guys really haven't dealt with yet. You probably will by the time you're taking ACT as juniors, but that's what's going on. But anytime these match like that, they just cancel, and you have the 17 over 3. All right. Take a break, get a drink, take a breather, and I believe you have reading next. I'm going to be back one more time before the end, but in general, you guys have been working really well, so good job.